Okay, so we are back to go over the comprehension of this text, and for me to support you with that, let's just remind ourselves that we are going to box domain-specific vocab. We're going to underline key details or supporting details. We are going to do a little upward arrow if something has, or if a paragraph has the same main idea, and if something is fluff, we just leave it alone, okay? Alrighty, and of course we're also going to be making some blurbs on the side like we've been doing this whole time. Alrighty, so, and the book obviously also has some of their own choices of DSPs as well. Alright, from When Stars Explode. What would you say is the topic of this text? Go ahead and just box right now, box the topic of this text. Okay, you should have boxed stars, which is also a DSV. And this is just telling me what they're doing. So this is probably something that I'm going to learn a little bit more about. Okay, so when stars explode. A supernova is the spectacular death of a star. Okay, spectacular death. When I think of the word spectacular, I think of something that is a big deal or something that takes up a lot of space, something that is loud. It's one of those kind of high energy words, right? A supernova. I'm gonna box that. I'm gonna box that word, supernova. Okay, it's one of our DSVs. Okay, the last time people saw a supernova in our galaxy was 1604. Fluff. That was before astronomers were using telescopes. Okay. However, every year astronomers see supernovae exploding in other galaxies. However, astronomers can often observe such supernovae for months before they fade from view. This sounds like a lot of fluff. It just tells me what supernova means. It's the death of a star, and it's kind of a big deal. So if I had to underline anything else at all, I would just underline that astronomers can often observe months before they fade from view. Okay. I can also underline exploding from other galaxies, but all of that is really just fun facts. The main point of this paragraph here is just telling me what is a super, and I'm going to abbreviate this too, okay? I don't want to put an S because of the word stars, so I'll just put, what is supernova, okay? SPNV is what I'm writing. It goes on to state, most supernovae, that's the plural of supernova, and pronounced supernovae, come from massive stars. Okay, that's an important detail right there. It's telling me where it comes from. So this one's telling me what supernova is. This one's telling me where it comes from or what it comes from. Antares is a massive star. So you can either say Antares or you can kind of say like an Antares. I've heard it said Antares. Sorry, Antares. This ES is actually an E's kind of sound, Antares. Antares is a massive star. Such a star is born with more than 8 times the mass of the sun. Such a star is born with more than 8 times the mass of the sun. If anything, I'll just underline more than 8 times the mass of the sun. It's giving me some details right there. But the main thing that it's telling me here would be where it's from. And if anything, at most, it tells me how huge it is, how massive it usually is, and from and size. Okay, and 2 quick little bullet points. When a massive star is young, it is hot, bright, and blue. Its center makes energy the same way the sun does. What do you think is more important, the colors of it or the fact that it makes energy? Okay, I'm going to underline center makes energy. The same way the sun does, by changing hydrogen, the lightest element, into helium, the second lightest element. Now, in past years, guys, I've seen where kids get kind of confused with this kind of wording. Remember, it's going from something that is light to something that is less light, therefore a little bit heavier. Okay, people just get a little bit confused with when it says second lightest. So it changes from hydrogen into helium. It reminds me of when you guys have learned in science about chemical changes. This nuclear reaction, ooh, definitely some DSV right there. Not to forget sun right there, and supernova again, supernovae. Okay. This nuclear reaction creates energy that heats the star and makes it shine. Okay, so it's telling me 2 things. Heats the star, makes it shine. Okay. I can definitely say that since energy is mentioned 2 times in this paragraph, main idea of this particular paragraph would be how it makes, and I'm going to put this for stars, how stars make, and remember I already said I'm going to use this little code for energy. All right, not to forget my text features. The exploding star that people saw in 1604 produced a glowing cloud of gas and dust called a nebula. Gonna box that one. The nebula at the left is all that remains of that star. Important or fluff? If you said fluff, you're right. It's just a fun fact. Wait a minute. As a good reader and as a test taker, if this were a test, what should I put on top of the word explode? When stars explode. What is it called when they explode? We just learned about the first few words right here. It would be called supernova. Okay? And I can also tell that it says the spectacular death of a star explode. And they kind of made this font, the way that they wrote this would be kind of like spectacular. Okay. It's bigger and brighter than the rest of the text in the title. All right, people. The outflow of huge amounts of energy, much of it light, pushes outward from the star's center. Okay, I'm going to underline outflow, much of it light, outward from star's center. It states this is good because the force of gravity pulls inward and tries to make the star collapse. There's that word. But as long as the star can make energy, it can fight the force of gravity and survive. For this one, you guys, I know that you guys know and you've heard that space is very, very cold. I want you to think about, when I read this is what I thought about. A balloon, think about an inflated balloon and what would happen if you were to place it inside of a freezer. What would happen to that balloon over time? It would deflate. And when you think of something deflating and getting all kind of small and squished up, I want you to think of that word collapse, just as a visual in your mind. Okay? Now, is this a new idea or the same idea as paragraph 3? Take a look at paragraph 3 about how stars make energy. You should have said that this would be the Same idea as paragraph 3. Cool. Alrighty. Paragraph 5, however, we know that's just a fancy word for but, a massive star must make lots of energy. Massive star must make lots of energy to fight the gravity of its own mass. So the star shines very brightly. As a result, we can easily see the star across hundreds of light years of space. This is a huge distance because 1 light year is the distance that light speeds through in a year, nearly 6 trillion miles. So this whole paragraph is mostly telling us all about, it's just telling us about light years. I would usually say that this is just a bunch of fun facts and it's a little bit of fluff, but the thing is that the author is taking a lot of time and dedicating a whole paragraph just to talk about light years, okay? Again, key stuff would be a massive star makes lots, or it has to make lots of energy to fight the gravity of its own mass. So think back to that little balloon in the freezer. Now a balloon doesn't make its own energy. It's saying that these massive stars do. So instead of it collapsing and squishing up, there's energy inside of it constantly being made. How is that energy being made again? All right, there's a reaction, a nuclear reaction that happens, and it goes from hydrogen changed into helium. So these massive stars, they need a lot of energy in order to stop it from collapsing. That's me trying to put it in its own words, okay? Or in my own words, pardon me. All right, let's keep it going. But because the star shines so brightly, it uses up its hydrogen, just what we said, uses up its hydrogen fuel. Fuel is something that keeps it going, it's keeping it alive within millions of years. Much less time than the billions of years the sun will take to use up its fuel. Soon, the star's center runs out of hydrogen. Then the star expands and cools, turning into a big red star like Antares. Astronomers call such a star a red supergiant. Here's that word again, Antares. It states right here that the star expands and it cools. The visual I want you guys to do for this one in your mind is when you think of, this is rough. I want you to think of a plastic bottle of water, and when you put that bottle inside of a freezer, what happens to it? What happens to that bottle? It expands a little bit. It stretches out inside of that bottle. Think of the same thing going on inside of here. Because usually when you guys think of heat, you guys think about it expanding. In this case, I want you to think of it expanding because it's cooling down. Just like when you put, like I said, this water in, if you put a full bottle of water in the freezer, you'll see it kind of like get a little bit bigger, okay? So let's see, or expanding rather, not necessarily being bigger. Soon the star's center runs out of hydrogen. What's going to happen when it runs out of hydrogen again? Bloop. Think of it collapsing. Then the star expands and cools, turning into a big red star like Antares. Astronomers call such a star a red supergiant. The red supergiant makes energy by changing helium and other elements into still heavier elements. Remember what I said right here, right? Hydrogen, which is lighter, turns into a heavier element, helium. So the author is just making a reference to that when the author says still. So elements are still changing from light to heavy, okay? So red supergiants makes energy, changing to helium, into other elements, still into heavier elements, okay? It's still talking about making energy. It says, but these nuclear reactions do not make as much energy as hydrogen did. Within a few million years, the star has no fuel left. Okay, gonna go back up just a teeny tiny bit, and I want you to pause for a second. Now that I've read these two, I want you to notate what you think the main idea of those little paragraphs should be. What should you write? Right here, I would focus on what happens when the star expands. And for this one, it's pretty much the same. And it still talks about how the supergiant, the red supergiant, makes, and you can write out energy, or you can just write it down like me, makes energy. Okay. All right. Ooh. Let me move this a little bit for you. In a star, two opposing forces are always at work. Remember, inside, it's it's changing around or changing from one element into others. And then the outside, it's like gravity is trying to pull and make it deflate, remember, or collapse. It says, in a star, two opposing forces are always at work. Gravity pulls the star's mass toward its center. If no force worked against gravity, the star would collapse. But energy in the form of heat and light pushes out from the center and works against gravity. So if that balloon inside of the freezer was making its own energy, it might have had a little bit of a longer life to stay inflated. It says, so long as the star, or this means as long as the star can make energy to fight gravity, it stays alive. All right. Now the star is in big trouble, so pause. This was just like the King George text when you guys read the front of a page or turned the page and you were confused. What happened in the last page? The last thing we read was, but these nuclear reactions do not make as much energy as hydrogen did. For what? What are they talking about? Oh, right. Red supergiants. Okay. Jumbo stars, right? Okay. Within, or massive stars. Within a few million years, the star has no fuel left. Right? Now the star is in big trouble when it runs out. I'm going to put runs out of fuel. Figurative language there. The star can't make energy to hold itself up, and gravity is still trying to pull the star inward. I'm going to underline can't make energy to hold itself up. And remember where we saw big trouble, it's a negative to a mood feeling. Okay, so the star's center, that word again, collapses. The center collapses. Let's relate this to the text feature that we're seeing. Scrunching itself into a small, dense object. Think again of that little balloon inside of a freezer, eventually deflating, and then dropping, okay? It says, so the star center collapses, scrunching itself into a small, dense object. Meanwhile, the star's outer layer, and this is what's different from that balloon image now. Meanwhile, the star's outer layer, because remember, what was the star making inside of it all along? It had the power to make energy. The outer layer shoots into space at millions of miles per hour. The star has exploded.